Hi, welcome back to my statistics class. Today we're going to use Geogebra to find the probability specific normal distribution. Okay, so now let's open our Geogebra. So we type in Geogebra. Again, on the upper right, you see a waffle icon. You click on the waffle icon, you will have Geogebra Classic. I will also put the link on the class. And then on the also upper right, you will see a sandwich icon, and then click on the three dot, you will see probability calculator. So by default, they will have a normal distribution. Okay, so here is you change the mu and the sigma. Okay, so now let's take a look at the practice. So how do you find the exact probability? Example 1, to use the Geogebra. Let's say if I want to find, let me give you some example. Try to find the probability that when x greater than, let's say 0.7, and then the probability that x less than 0.3, and then the probability that x in between 0.3 is too small. Let's do 1.3. Sorry. It's fine. Less than 0.3 is fine. And then the probability that between 1.5, it's just random number, and then negative 0.8. And then what about the probability when x is greater than 1.5 or x less than let's say 2? No, less than 0.8. Okay, so now let's just try to fill in this with our Geogebra. Okay, when you open Geogebra, you will see all of these options. So you see the bracket in here. This means in between two value. This means outside the two value, greater than or equal to. You can tell by the shady area of the graph. So this part means when x is greater than certain value. So the first one is when x greater than 0.7. That means we need to use that one. When x greater than 0.7, we type in 0.7. So see, we have what? 24.2%. Okay, so this B is when x is less than 0.3. Less than 0.3 means we want the shady area is on the left. That means less than, but it's 0.3. So we change the number here in 0.3, which is 61.79%. Okay, so for in between value, which is in this one, we have what? In between which two value? Negative 0.8 and then 1.5, which gives you 72%, approximately 72.13%. And then now the third one is when x is greater than 1.5 or x less than 0.8. So now let's take a look. When x is less than 0.8 would be in here, right? Greater than 1.5, which is here. So the total shady area would be 85.5%. Okay. Now let's have more exercise. This is teach you how to get used to the bracket and the equal sign on the probability. So now the next one is, in the medical study, the population of the children in Wisconsin were found to have a serum cholesterol level that were normally distributed with the mean. So we know that this is normal distribution with a mean 1.75 and sigma standard deviation is 0.3. Define and draw a normal model for the children's cholesterol in Wisconsin. So we know that this is normal distribution. the center is going to be the mean, which is 1.75, and then you have 1 standard deviation, 2 standard deviation, and 3 standard deviation. Each standard deviation, you just need to add and subtract 1 sigma. So 1.75 we add 0.3, we have 2.05. We subtract 3, we have 1.45. And then we add 0.3 from the first standard deviation, we have 2.35. And then we subtract, we have 1.15. And then for the third standard deviation, we have 2.65. And then here we have 0.85. So this is the standard deviation model. That's the normal distribution model for the children's cholesterol in Wisconsin, cholesterol level in Wisconsin. Okay, and then B is a child has a cholesterol level of 2.11 milligram per milliliter. What's the percentage of children in Wisconsin who have cholesterol level that are higher than that children? So we're trying to find the probability with the children who have a higher cholesterol level greater than 2.11. So now let's use GeoGebra. And we're going to change the mu become 1.75 and sigma is 0.3. And then we want it to be greater than. We want s greater than 2.11. So it's going to be what? 0.1151. So we can convert this to a percentage. Again, from your homework, I want you to have a screenshot of your GeoGebra graph to show your work. Okay, found percentage of children in the Wisconsin who have cholesterol level between means what? 1.30 less than or greater than, x is greater than 1.30 and then less than or equal to 2.3. So now let's open our GeoGebra. So we know that we need to pick the in-between ones, which is in here we change to 1.3 and then here would be 2.23. Okay, so it turns out the probability is going to be 0.8784. Which is 87.84%. Okay, so that's easy, right? So let me know if you have any question about the GeoGebra.